All right, I'm going to show you guys 10.3 parametric equations. And so we're going to learn some different things that we can do with parametric equations. We learned on the previous video slope, so when we take a derivative of the y, remember y and x are in terms of t. So when we take a derivative of y, we get dy dt, take a derivative of x, we get dx dt. If we put dy dt over dx dt, we get slope, dy dx. So dy dt over dx dt is our slope. Obviously, you can't divide by 0. We don't want the bottom one to be 0. But we've done slope before. But the one that stumps people, and I could probably explain it 4 times, and some of you won't quite 100% get it, but they're saying you take a derivative with respect to time of the dy dx. So after you find dy dx, you're going to have an equation and still in terms of t. You take a derivative of that over dx dt. Now, we're not going to need a third derivative, but you would take the derivative of the second derivative over dx dt. The fourth derivative would be the derivative of the third derivative over dx dt. It's always over dx dt. Let me show you why. So if you look at this cleanup, that's pretty much what the top says right there. D squared y over dt dx over dx dt. If you flip over, because you're dividing by a fraction, you'll see these dt's cancel. And you have d squared y over dx squared, which is the second derivative. So that's kind of your validation that, okay, that will give me the second derivative. So all you have to do is remember, take the derivative of the first derivative over dx dt, okay? But it stumps people. So this says x of t. It could just say x equals, but x of t, this says in terms of t, of radical t. And then we got y of t is 1/4 t squared minus 4, okay? And they said the time is greater than 0, so we're starting at 0 on. Find the slope, concavity, and speed. So let's start off with slope. Remember, if we find dx dt, it's 1/2 t to the negative half, or 1/2 radical t. Derivative this one, again, if I distribute in first, it's just t over 2. dy dt is t over 2. All right? So we got to find slope. So slope, remember, is dy dt over dx dt. So I get t over 2 over 1/2 radical t. So that's going to give me t to the 3/2. All right, so I get t to the 3/2. So now I have the slope at all points, t to the 3/2. Well, they asked me to find the slope at the point 2, 3. I know t, that's x and a y. If I have an x and a y, and I need a t, how do I find it? Well, here's an equation that has an x and a t. So if I know x, I can find t. So if I plug in 2 here, I get 2 equals radical t. Solve for t, square both sides, t is 4. So let's test it out. If we plug in 4 into this one, 16 minus 4 is 12, divided by 4 is 3. So it gives me the y value 3. So if you could have said the y value 3, solve for t. Now if you solve for t, you would have got plus or minus 4. But we're trying to find out the time when they're the same. This one's only plus 4. You can't take a square root of a negative number. So, and we also want t greater than or equal 0 anyways. So t equals 4 is when we are at the point 2, 3. All right? So verify that, plug 4 into both those and see if you get 2, 3 if you want to double check. All right, so now we can find the slope at t equals 4. And I get 8. 4 to the 3/2. Square root of 4 is 2. 2 cubed is 8. So now we know the slope of the tangent line at that time. Concavity is the second derivative. Remember, if we get a second derivative positive, we're concave up. If you have the second derivative negative, it's concave down. So remember, the second derivative is the derivative of dy dx. So I take the derivative of that. So the second derivative is the derivative of this, which is 3/2 over, remember, it's just over dx dt, which is 1/2 radical t. All right, the radical t will flip up. Just give me 3t. So if we want to check the second derivative at 4, you would get 12. 3t, so I get 12. Now I've had people go, well, answer's 12. Well, you need to tell me what it means. I got a positive, so it's concave up. So we're checking for concavity. All right, concave up. All right, now, third question is the speed. Well, speed is radical dx/dt squared plus dy dt squared. This is the same, saying the same thing, just in a different format. So to find the speed, all right, it's radical dx/dt at the point, whatever it's checking, squared. So if I square dx/dt, I get 1/4, 1 over 4t. But what I want to do is I want to find dx/dt at 4. So what I can do is, if I find this at 4, I get 1/4. If I find dy dt at 4, I get 2. So dx/dt is 1/4 squared. So it's 1/4 squared plus 2 squared. So radical 4 and 1/16 looks like 65/16, something like that. All right, and then I did that in decimal. I had it written down somewhere, 2.0156, I believe. And that's how fast, feet per second, whatever. Now I want to remind you of some things. Speed is the absolute value of velocity, okay? So we're finding the speed or absolute value of velocity at this time, all right? That's important to know. Now, because speed is always positive, it's absolute value, radicals are always positive, it works great. Where does this formula come from? So if we have a curve and we want to know the change from here to here, we want to know like how fast it's traveled. Well, I could find this speed, dx/dt, this speed, and to find that change, you can see the Pythagorean theorem coming in. We got the change in this squared plus this squared. So this is just Pythagorean theorem to find out how fast it's changing this way. And that's why that's your speed, all right? So the change in your position over time is speed, and this one we get 2.0156, all right? So that's where the formula comes from. You can see the Pythagorean theorem, this squared plus this squared equals this squared, or square root of that, all right? So now we're gonna find arc lengths. I got a problem for you. So wrote down the problem somewhere over here. Here we go. No, that's not it. Yeah, x is 2 sine t. All right, and y is 2 cosine t. And we're going to find it from 0 to 2 pi. All right, so here's example 2. All right, so arc length is the integral of radical dx/dt squared plus dy dt squared. And that was speed. Now, let's think this through. We learned in AB that the integral of the absolute value of velocity is distance traveled. So speed, that's the integral of speed. So and speed is the absolute value of velocity. So you're actually finding the distance it travels or the length of the arc, how long it is. So that's why that formula works so good. So we'll use it oftentimes for distance travel. They'll say, hey, how far did the particle travel from here to here, the distance? And you just do the arc length, which is the distance it travels. So the symbol we use for arc length is a little s here. So, and it's integral from 0 to 2 pi. dx/dt squared. So radical, well, dx/dt I need to find. I didn't really write it, give myself a lot of room there. I'll leave it. This is 2 cosine, and dy dt, negative 2 sine. Not a big deal. So dx/dt squared is 4 cosine squared plus 4 sine squared. And we could punch in our calculator and get the arc length, but I'm going to show it by hand. If you recognize, I could factor out a 4 here, and sine squared plus cosine squared is 1. So I'll actually just have square root of 4 here, or 2. So this is really the integral of 2 from 0 to 2 pi. Do that one by hand. Integral of 2 is 2t from 0 to 2 pi. And we get 4 pi minus 0, 4 pi. So the length of the arc for this is 4 pi. Well, here's why. What I gave you was a circle of radius 2. This is actually, if I put it together, it would be actually a circle of radius 2. And the distance around would be the circumference. Circumference is 2 pi r, radius of 2, 4 pi. And so this will be another way we can find the distance around the circle or circumference. Okay, but we're going to use it to find, like, the length of an arc. Hey, how far does it travel from here to here, or something like that. So really helpful in finding the distance when it started here, ends here, how far that was. Okay, all right. So that is parametric equations, and we'll do polar after this.